Hey everyone, in this video I want to talk about credential and token theft and some of the things we can do to protect ourselves and our users from it. And I always think about layers. We can think about, well, there's the credentials, then there's the tokens, and what are the various attacks and the protections we can use with those. We often hear about attacker or adversary in the middle. We think of different classes of attacks. We might have bad things on our machine. We might be tricked by, hey, connect to this Wi-Fi to connect to some bad network that maybe has some terminating TLS proxy or some other device that tries to do bad things. And so I want to talk about those different elements. If we go back to the first layer and think about credentials. So I have my user. And obviously my user has a specific device. I'm going to draw a really big device so I can do other things with this device later on. And then what my user in this case is doing is I'm going to authenticate to Entra ID. So I have my particular Entra ID tenant for my organization. And my authentication is all about proving I am who I am, so that then Entra will give me some nice tokens I can go and give to resources that let me access based on the permissions I have on that resource. So against Entra, I want to perform an authentication. And we think, well, there are different levels of protection and strength for those types of authentication. And depending on which one we use, those bad actors, we draw those in red, have different levels of happiness because how easy it is to compromise and do something. So I could think about, well, I do a password only. And in this case, our attacker is very happy. They're super happy. Or they're a cat, or they're a devil or a cat. They're very, very happy because it's super easy to compromise. If I get your username and your password as an attacker, I can then use it wherever I want, assuming you don't have some other conditions on the resources like a network location or a health of a device or a state of the device in join. But this is terrible, and everyone kind of knows we don't like this at all. So then I can think about, okay, well, I have a password plus some basic MFA. Now there's levels even in there. There's an SMS text message or phone call, and then we can step up a bit to the Authenticator app, where maybe I have to type in a certain number. It shows me the context. Hey, you're trying to use this in this application, in this location, type in this number. But it's still relying on the human to say, hey, here's this number and type it in. And even here, the bad actor, well, they're still pretty happy. Because what they will now do is they're going to phish the user. They're going to go phishing. They're going to attack. And, they're prompted and challenged with this code, or they need to type in the code from the text message. Well, they phone up the user. Hey, I'm from your IT department. We've noticed some suspicious activity on your account. But first, I need to validate you are who you say you are. I've just sent you a code, if it's text-based thing, or I'm going to send you a challenge. I need you to type this number in your Authenticator app. Oh, okay, I should probably do that, says the user, and they're authenticated. So you're relying on the user to understand what's happening, which is phishable. They can be tricked. So we don't like that. So then what we'd rather have is either it's this password plus phishing resistant, or we are passwordless. This could be hello for business. It could be a passkey. And that passkey could be like a FIDO2 token. It could be using your iOS, your Android device with the Microsoft Authenticator app. And the whole big deal about that is, I did a whole video on passkeys, is it requires proximity. So my iOS or Android, it uses a Bluetooth to check I'm close. And the whole point here is now that bad actor, they're very sad, they can't trick the user into performing that strong authentication for their remote session somewhere else. It won't work. I have to have the proximity to it. Or again, I've just completely removed the password. I'm doing that very strong authentication that requires the proximity. Hello for business, it's in the machine. It's the TPM in the machine. Passkeys or FIDO, it has to be either connected or a strong proximity via Bluetooth to it. So it protects me from this. So we like this. So from a credential perspective, this is what we want to do. And we can drive the requirements around this. If we go and look, for example, at our conditional access, one of the things we have is authentication strength. And there are ones that are built in. So we have phishing resistant MFA, for example. And if you go and look at the phishing resistant MFA, it tells you, hey, it requires hello for business or passkeys or certificate-based auth. I can create my own ones, but then I can require those in my policies. I can say, yes, I'm going to let you use this app and this resource, but my control is going to stipulate a specific authentication strength. So I can drive that as part of my environment. So this is kind of a step one. So in my step one, I think about, okay, great. I definitely don't want just passwords. And what we really want to be doing is we're leveraging conditional access. Remember, that's a P1 feature. I don't have that in the free version. And what I want here is I can use those authentication strengths. Remember, there are other things as well. I can do location-based. I can do the health of the device. Is it compliant according to Intune? And Defender for Endpoint can feed into that. So there's many other things. But in terms of just the pure authentication of credential I'm using, hey, this is great. And I mentioned that idea of, well, that registration of the device and registration of these MFA credentials. So one of the things I can also stipulate in conditional access, which is really nice, and we jump back to that for a second, is think about, okay, well, when the user is new or they want to add a new strong authentication and MFA method, well, what if a bad actor compromised the credential and then registered their own MFA? So one of the nice things I can do is when I think about target resources, if I jump over to here, I can actually select user actions and I could add a policy around registering the security information, or hey, even registering or joining a device, which is really useful as well. But for the registering security information, for example, I could say, hey, to actually perform that MFA registration of a new strong authentication method, you have to be on a compliant device. So it can't just be performed from anywhere that may have compromised that credential. So I can strengthen the onboarding of those strong credentials. And I can also strengthen, hey, if you want to join a device to your corporate environment, to your Entra tenant, I could add requirements there as well. So these are super useful things, and I would want to leverage that. Okay, great. What can we do? So yes, there are things we can do as the company to use authentication strengths. I can have policies around the user actions, so I'll add that in as well. But also, honestly, what's really important here is think about, from a user perspective, what can I do to help them? And some of the big things we can just do is help educate them. And we see this all the time. But give them education, help them understand phishing attacks, the types of bad things people might to do. With Office 365 Defender, what's kind of nice, and it's kind of mean as well, but I can do phishing simulations. So they'll get the email, and then you can track, well, who clicked on it, to then maybe go back to them and reinforce and say, hey, look, this was a phishing attack. You clicked it. Okay. These are the things to look for. If ever you're not sure, this is who you would go and contact. So we help educate them on those things. Now realize a lot of these attacks, I just said, oh, you got an email. So realize we get that email, for example, coming in. And that email may have links. We're trying to get them to click on something. It may have some attachment. And so what we can think about doing is we scan those. So I can do scanning as it comes in. And again, this would be something like Office 365 Defender is an example. So we're trying to protect the user as those potentially bad things come in and try and trick them into clicking the bad link or opening the bad attachment that then does something bad. Realize the users also like the internet. So we have the internet over here, and maybe they got some bad link or they're just browsing around and the user, hey, I like the internet. Well, one of the things we can now do is we do limitations. And there's a whole bunch of different ways I can do that. I can think of network appliances, things like Azure Firewall can do layer 7 inspection. I can have categories and block certain things. I could have a proxy on here. I could have client-side components like Defender for Endpoint, which can do web content filtering. There's Defender for Cloud Apps that could restrict me trying to get tokens to different things. There's things I can do, but try and limit what they can get to. It's all about trying to protect the user from those various bad things that's trying to trick them, that's trying to get them to do something we really don't want them to do. So we do this stuff. We educate, we have the strong authentication, and let's say we are successful. So the bad actors now have to shift. So they'll shift from trying to get the credential to, well, what could they now get? What is the point of this authentication? So the whole goal of the authentication is what's happening here is once I've done that authentication, my Entra tenant will issue me tokens. Now, there are actually a number of different types of tokens involved. There's ones around the initial authentication that I get, and then there are ones when I want to access a specific resource from a specific client application on my device. I'm going to focus on the concept that my device is Entra registered or joined, which really also means it's probably going to be managed in some way by that. And while I'm saying this part is because when I register or join a device to Entra, a few things happen on the machine. As part of the registration, when I join the machine, firstly, on this machine, there's going to be some cryptographic hardware. Now on a PC, we have that trusted platform module. It's got anti-hammering. TPM v2 is what we like, but on a Apple device, it has a hardware cryptographic. Android has it as well. When I go ahead and register or join my machine, two pairs of asymmetric keys are created. Asymmetric means what one key does, the other key is required to undo. So if I encrypt a message to you with your public key, that everyone knows, only your private key can decrypt it, and your private key you keep very, very secure. In fact, when I think about those private keys and those pairs, there's device key pair. And so with the device key pair, what that means is the device key private key gets stored in your TPM. And then there's a transport key pair. And so the transport key private gets stored in your TPM as well. So just as part of registering my device with Entra, so now my device actually has an object in your Entra tenant. We have this device and transport key pair, and the private keys are being secured in the cryptographic hardware of the device. Again, Windows, I'm going to talk about a TPM, and we like that TPM v2. So the device key helps identify the device. The transport key helps us to secure things we transport between the machine and Entra. So we've established that the device is registered. So we have these nice capabilities to have secure proof between the machines. So when I perform my initial authentication on a device or hybrid joined machines, what it's going to create for me, so Entra goes ahead and is going to send me back for the initial auth. So this is the auth. It's going to send me back a primary refresh token. So that primary refresh token, is placed on my machine. Now, there are other components involved in this, which I'm going to talk about later on. This is not saying I just do myself in my application. We're going to use the Microsoft account brokers to do this, and it will manage all of this for me. But for my authentication, hey, I'm going to get this primary refresh token. Now, that's valid for 14 days, and it's going to continually automatically refresh either periodically or when I perform some actions, providing I continue using that device. And I can actually see that. So if I jump over to a machine, if I go and look, so this machine is joined, one of the things I'll see up here is my, it's gone past it, I think, there we go, single sign-on state. I can see I have a primary refresh token up here. And we can see it lasts for 14 days, from the 22nd through to the 6th. So I have that on this particular machine. Fantastic. That primary refresh token can then be used to go and get other tokens for other resources. So it's super, super powerful. Now, as part of getting the primary refresh token, again, I can only do it if my device is registered or hybrid joined. And so what it now does is, along with that primary refresh token, Entra also creates a session key. Now, this session key, it encrypts. So what it's going to do is it's going to encrypt that session key with, you guessed it, the transport key. So it can encrypt it with the public transport key, because only then the person that has the private part of the transport key, because it's asymmetric, could decrypt it. So then only this particular machine could decrypt and get this session key. Now that session key it generated, that is also stored in the TPM. So now we have this shared symmetric secret that is hardware bound inside that TPM. And the other thing it does, it actually embeds the session key as part of that primary refresh token. So that session key is also embedded within here. So now there's a hard link between the primary refresh token and that session key, that secret shared between Entra and this specific machine, because it's bound inside the TPM or whatever that cryptographic hardware of whatever device you're using is. This binding between the primary refresh token and that secret that's securely hardware bound is super, super important, as we'll see later on. So now I have this primary refresh token that's super useful, and then I want to go and access some resource. Well, when I'm actually authorizing, so if I think about what's kind of my authentication, now if I want to actually go and get some access to something, it's going to send me a refresh token, which is specific to some app on this machine, and then an access token. Refresh tokens are very long-lived. It's 90 days by default, and again, they're going to continually refresh every time I go and get a new access token. If it's a single page app, it's only valid for 24 hours. The access tokens are super short-lived. They're 1 hour typically. Now, I can get longer-lived access tokens if I can combine it with other technologies that lets me revoke it. Because the whole point is, ordinarily, I can't revoke an access token. Once it's generated, it's out there. And so you keep them pretty short-lived in case they get compromised, in which case they can only be compromised for an hour. But if we add in some revocation technology like continuous access evaluation, which I'm going to talk about, then we might make it a 24-hour long token because we do have the ability to cancel it out if we have to. So then we also might get these refresh tokens and the access tokens. So now on the machine also, I've got this refresh token and access token for a particular client on this machine. A different client would have its own set of refresh tokens and access tokens, etc., etc. And so when I want to access resources, I would now go and send that access token to the resource that I want to go and access. So that's the whole point about this. Now, if you hear the term session token is just a superset of the refresh token and a session cookie we put in the browser for browser-based single sign-on. And the things I'm going to talk about will work with those browser-based credentials as well. Okay, so at this point, we have tokens. And it's the tokens, and specifically the access token, that lets us go and talk to a particular resource, while the primary refresh token and refresh tokens let us go and ask Entra for that access token to go and do stuff. So these tokens are sitting on the machine. And so if I think about the bad actor, this is now what they shift their focus to. And specifically, these refresh tokens, or the primary refresh token, would be the biggest target because they're longer lived and I can use it to go and request access to something else. So the whole point of what's going to try and happen here is that bad actor. So I've got the evil person. So the evil person on their evil machine, so here's the evil machine, they would try and take these and copy them. So now on their machine, they've got, for example, maybe that primary refresh token or the access token, and then they would try and take the access token and try and talk to a particular resource, or maybe try and take that primary refresh token and say, hey, I need an access token for this thing. Please give it to me. So they're going to try and copy the tokens. How? How would they be able to copy these tokens? Well, they've got one or two options available to them at this point. They either get something evil on the machine, some piece of malware, or they put something evil between the user's device and the network. That's what they can do. And again, this comes back to, hey, there's some malware that they got tricked by clicking a link or opening an attachment or putting in some USB device or someone sent them something. Or, hey, connect to this free Wi-Fi. Oh, yes, please. And then that Wi-Fi is not very good. They've got some terminating proxy that terminates the TLS. They can go and get to the stuff. Or they trick them to perform some other authentication once they're connected to this, and they steal the tokens that get generated. There's tools out there to do exactly that. So now I need to think about, well, how do I mitigate these things? How do I mitigate those two scenarios? And I'll actually start with the network one. And so on the network side, the mitigation really becomes, I need to be able to trust the network. And so that's where we have things like the Entra internet access. And what internet access does is it installs that global secure access client on the machine. And what I can do with that is if the GSA is on the machine, which means it's being secure, the traffic is going via the Entra, I can consider that a compliant network resource. I can enable an adaptive check. So if I jump over and I go and look at my global secure access, and within here, I can look at my global settings, session management. We have this adaptive access, and I can turn on enable global secure access signaling in conditional access. And what that would now let me do is, as part of a policy, if I just look at any policy I want and I look at my networks, what we now have the option is I could exclude all compliant network locations. So I can start to do policies in here that require me to be on the compliant network that I'm leveraging Entra internet access to secure and protect against going to some bad thing. I can't be tricked to go to some weird appliance. I'm going to go via the Entra secure edge for all of that internet-based traffic. So I know it's on a compliant network. So that can help me protect against that type of attack vector. Okay, so that helps here. What about bad things on the machine? So this is where our normal considerations for managing devices come into play. I mean, fundamentally, to protect this, I have to be able to manage the device, which generally means it's going to be registered or joined, and I'm managing it with an MDM solution. This could be Intune, for example. And what I can do with that is I can apply policy. And policy can restrict the types of apps I'm allowed to run on this machine. There's adaptive technologies that can help control what's leveraged in the organization, what's typically used. I can install things like Microsoft Defender for Endpoint, which can help look for known, unknown types of vulnerabilities, looking for types of threats. And it reports all of those things in centrally, so I can then look at attack stories and track exactly what's happening. Because that best defense, honestly, is to not let it get on the machine at all. So that user education was important. So when we talked about that phishing simulations, educating, blocking the bad links, blocking the bad attachments, limiting the access, well, that would all help stop the bad stuff, those evil executables and scripts, whatever, getting on the machine in the first place. So we want to do that. But then that anti-malware to detect and remove, that's really important. And additionally, when I have these things in place, when we talk about our conditional access, I can use that as a signal. So one of the things we just saw was, hey, the idea of a compliant network. I can require that before I let you go and request an access token for some resource, but I can also require a compliant device. And the status of that compliant device, that's being fed in by Intune, which itself can get signals from Microsoft Defender for Endpoint. So all of this helps give me that confidence that, hey, this device is healthy. I'm being protected from the bad things getting on it in the first place. And if some bad thing gets on it, if the device has been jailbroken, it won't be compliant anymore. And so then when that thing, if it's on the device, tries to request an access token, it's going to say, no, you're not healthy. You're not on a compliant network. I'm not going to issue you these tokens for you to then go and do various things. So that's kind of a key important point for that. And actually, I really don't like that I wrote obviously there. That's not really accurate. I'm going to take that out because the refresh token is still all around the authentication part. So yeah, really, this part should be more kind of up there, and then authorization would be more the access token. Tiny detail, but that was bugging me. Anyway, we're doing all these things. Nothing is perfect. We're doing different layers of protection. We always think defense in depth. We think layers in case one thing fails, but things will happen. So what can we do, assuming we're now post-breach? This has been successful. The evil stuff got some network of it on the machine and it has stolen the token. Like, we're now in that scenario where the tokens have been compromised. What can we do to limit, if someone does copy the tokens, their ability to actually leverage the token? And so we're thinking here about what we really need is some ability to take the token, and what I want is token binding. I want this particular token to be bound to this particular machine. And so if I try and use the token from a different machine, it will fail because there's going to be some proof. I'm going to have some element that will prove, no, I'm allowed to use this token from this machine. And that proof will be bound within this. Specifically, some secret that only this machine knows. Now, if I think about what I have in the Microsoft world with an Entra registered or joined device, I need a secret that's cryptographically hardware bound to the machine that the attacker can't steal. Because think about this, if the attacker has some evil thing on the machine, if it's just some random secret that's in memory, sure, it would protect me from the network-based scenario where they don't have something on the machine to read a secret. But if I'm an evil bit of software on the machine and I have the ability to take the token and the secret is just sitting in memory or some config, well, I'll steal the secret as well. So that doesn't work. I need the secret to be hardware bound inside the machine. So in our scenario, okay, I'm Entra registered or joined, I have this really nice session key thing that is hardware protected and cryptographically bound to this machine. And so we'll use the session key, which remember is also embedded and linked as part of the primary refresh token, realizing this is the biggest target that those bad people are going to do. And so what I now want to be able to do is when I want to use my primary refresh token, I'm going to perform something called a proof of possession. So I'm going to prove that I have the session key when I want to do some request to Entra that only I can do because only I have this secret. So what it looks like is, okay, I want to go and get an access token. Now, maybe I'm using the refresh token or because I've already requested it for this app before, or let's say it's the first time I'm using the primary refresh token. So what I'm going to do is make a request against Entra. So I'm going to say, okay, what I want, I'm going to do a get. I want to get an access token, please. And I want to get it by proving I'm allowed to get stuff, because I'm going to give you my PRT. Or again, maybe I've already got a refresh token for this particular client application. So here's my primary refresh token or my refresh token. Please give me an access token for this target resource. But we're adding in the token binding. So what we're going to wrap around this is we're going to say, well, actually, we're going to perform a signature around that primary refresh token or refresh token we're sending, and we're going to sign it with the session key. So we're sending to Entra, hey, I need an access token. Here's my primary refresh token, and I'm signing it cryptographically with this session key. So I would use the capabilities of the TPM and say, hey, here's the PRT, please sign this for me. It returns the signed version. I send that to Entra. Entra now validates the signature. Remember, the session key was embedded as part of the primary refresh token, so it knows that, oh, this is the corresponding session key. It has the session key because they share that between them. It performs the same signature, make sure those values match. If it matches, okay, great. You were successful. I'm now going to give you your access token that you've asked me for. And because, again, we have that session key, what it can actually do here is in that response, when it's going to send me, oh, wrong color, when it's going to send me back my session key, sorry, my access token, so it's going to go ahead and generate that. So it creates my access token for me. And remember, it will also create or refresh my refresh token for that particular client application, and potentially maybe the primary refresh token as well. But what it's going to do, it will actually encrypt all of that with the session key and send it back to me. Now, I'm legitimate. I've got my access token. I can go and connect, send that to my resource that I've been authorized for, and I'm very, very happy. So fantastic. I've bound it to the machine, that proof of possession. Remember, the bad actor, if the bad actor said, okay, I want to do the same thing. So the bad actor says, okay, I want to get an access token and I'll send you the stolen PRT because I'm evil, I've got this stolen PRT. Well, when it looks, the PRT has that embedded session key. It's a bound token. And this is going to be like, no. And you're blocked. It won't let me use that stolen PRT. And again, this is always going to be the case when I'm an Entra registered or join machine. I'm always going to have that PRT. It's always going to have that session key. It's always going to be able to do this token binding. And actually, it does this by default. Funnily enough, if I go and look for a second, you may wonder, well, how do I turn this on? It happens without you doing anything. So if I go and look at my sign-in logs, and I need a machine, I need one that I know is from a joined machine. That one. So if I go and look, what I'm looking for my sign-in is it's bound. There is no configuration I've done here. This is not a policy or a flag or something I have. This just is. So you get this by nature of using the primary refresh token and being an Entra registered or joined machine. And what's taking care of all of this in all of these situations is the idea that on my particular device, no matter what that device is, we have the token broker. Now on Windows, this is WAM. WAM. So the WAM is the Web Account Manager. That's for Windows 10 and above. On iOS and Android, then you're using the Microsoft Authentication app. And it just takes care of all of this stuff for you. And if I'm writing an app, as long as I use the MSAL, so the MSAL is the Microsoft Authentication Library. It will automatically use the broker for you. The broker will automatically actually cache things like the refresh token. It will automatically deal with the primary refresh token. All you'll ever get back is the access token as the app. You won't even see the refresh token. So when you're writing an app, if you use the MSAL, this is all done for you, and it will future-proof you as maybe changes happen in the future. Note, this also applies to the web browsers. Edge, it's just going to work. Chrome, there's a Windows, I think, sign-in extension. For Firefox, there's a configuration you make in the browser. But then the broker will also take care of injecting into the browser the required cookie. I get this session cookie that handles that single sign-on and handles all these protections, everything else for you. So use the broker, use the MSAL in your custom applications, and you just get this token binding. And that's a huge amount of protection just straight away by having that Entra registered or joined device. And it's just happening behind the scenes. Now, there is a step further you can go. If we go and look for a second, and I look at my conditional access again, and I look at my session controls, you will notice I can require it. Require token protection for sign-in sessions. So this is basically saying, hey, look, I always want the token to be bound, which means it's always going to be a primary refresh token and not just a regular bearer refresh token or unbound session cookie from a browser. But you have to be careful with this, because as soon as I check this box, whatever applications and users I've configured this for would now get blocked if they can't meet this requirement. Now, the page on the documentation that talks through this really does highlight the requirements around this. So it's telling you what it's working for today. So it has to be Entra joined or hybrid joined. These clients work today. There are limitations on it. Again, this is a preview feature right now. You just have to be super careful. And it even tries to guide you through. It's like really the focus is Exchange and SharePoint today to lock those down. Use Windows only, mobile apps and desktop clients, and then sure, go ahead and use this setting, because otherwise you're going to end up locking a bunch of other people out who maybe are not doing this. Now this is expanding though. I mean, the key point of this is technically if my app, and you would want to do testing, but if my app uses the Microsoft Authentication library, which uses the token browser, this should work. But that's the critical part. It has to be using the token browser broker, because it's the token broker that can get primary refresh token that can do this token binding. So that's the scenario we're in today. Note, this token binding is a proprietary Microsoft solution. The challenge of tokens being stolen has been around for a long time. Now, it's still a tiny fraction of the types of attacks, but it's growing as people get much better about protecting these things. And so it's a very real threat. Now, there were competing approaches, if you think about VHS and Betamax and Blu-ray, and I can't even remember what the other one was. It HD disc or something? I don't remember. There's competing standards. So Microsoft took one of the standards that was being discussed. It was focused around access tokens, I believe, but they changed it to really focus primarily on the refresh token because that was the bigger target. But there is now, very recently, I think it was September 2023, a standard that was ratified around adding a new type of token that would be this demonstrating proof of possession, where it would bind the token. This was RFC 9449. Some vendors are starting to implement this. And it's going to work very, very similar way. Private key, public key. It's doing this binding to the tokens, and you have to have that proof of possession. So it's going through really all of the same things we're doing here to have that. It works for refresh and access tokens. The challenge with the standard as it is today, it doesn't really stipulate much about how you handle that private key. And as we talked about, if you just implemented it and stuck that private key in memory, sure, it's going to work fine for those adversary in the middle type scenarios, but it's not going to work very well if I've got evil on the machine that can go and grab the private key as well. And so the approach of that secret that demonstrates the proof of possession actually being hardware bound, I think that's an important point, which is what the Microsoft solution that they have implemented today does. Now, given that it is now a standard, and this is just my guess, I would assume at some point Microsoft will start to build that in, but I would imagine they would still use this for the securing of that proof of possession that they implement. But my point here is, yes, there is a standard out there very recently now, but that is not compatible with what Microsoft are doing. So if you went and implemented that, it's not going to work. Also, it would require an OpenIDC federation, which many things don't federate using OpenIDC. They might use SAML, for example, to federate with Entra. So you have to have both the IDP and the resource supporting it. And so Entra today in the Microsoft ecosystem does not use that RFC, whatever I said it was, 9449. Who knows what happens in the future, but it does not today. So that wouldn't help you with the Microsoft services. Then I can think, hey, detection. Like, how do I know if it's actually happened? What can I do to prevent, if none of this has worked, maybe the access token was stolen, which is short-lived, but I want to do something around that. Maybe I want to go and revoke tokens. So this is where we have the idea of continuous access evaluation. So the point of continuous access evaluation is I can use it to revoke tokens. And what this could be based on, for example, is I have my continuous access evaluation. It ties in to conditional access. And maybe my policy had a certain network location. Well, then I go and steal an access token. I try and use it from a different network. It's now would fail that conditional access policy, and it can revoke the access token. So even though the access token was given out, when I use continuous access evaluation, it understands what the conditional access policy was, and it can now kick it out. I could also, for example, maybe I'm detecting weird things happening in the environment, and we have identity protection. And specifically, I might think about user risk. Well, if suddenly I see the user risk go to high, that's a critical event. And that critical event can then trigger continuous access evaluation to revoke the token. And so identity protection has a whole set of capabilities around detecting token theft. Now, they do not disclose how they do it, because then you'll be telling the bad actors, oh, we're looking for these things. And the bad actors say, oh, well, I won't do that anymore. That'll not be very good. But there's a whole set of things they look for to detect token misuse. And then they can raise that user risk. So then I could trigger off of that. So these are all very important things to have in place. Obviously, identity protection is a P2 feature. Just call that out. So if I use user risk as part of my conditional access, I need to have the P2 license to leverage that. But these are all things that can help detect and respond if the token has actually been stolen, and revoke the token, perform other things based on that user risk. If I see the user risk is high, I might require a password change, which would then revoke all the existing sessions, etc., to clear that out, which is another reason we like to protect registering strong authentications, to stop the bad actor being able to go and meet and perform that password change or something else. So I talked about a lot. Where you sit in terms of what you really care about will vary. If you are some tiny, tiny organization that's not part of any supply chain from maybe other companies, you might say, I don't worry about this stuff. I'll just do some strong authentication. Realistically, though, most companies should care about it today. And what that really means is my devices, yes, I do this stuff around the credentials, but I need to manage the devices. I just do. I want them Entra registered and joined, so I get these nice bound primary refresh tokens within my environment and the associated other tokens that then get generated from it. And this is expanding. I then can do things to stop bad stuff being on the device. I might do things to stop bad things being able to get in the middle of the user's connectivity. Now, what that does mean is, hey, I can't go and use grandma's PC anymore to go and check my email when I'm visiting grandma. I don't know what websites grandma visits or what grandma clicks on, but they wouldn't be able to do that anymore, because as soon as my conditional access policy says, hey, you have to be device healthy, compliant, joined, I can't use other machines. I mean, there are things you could do. if I want to be able to let users just ad hoc access corporate resources, I mean, one option is you deploy something like Azure Virtual Desktop, which has the applications or just a browser so I can use the client base. And if the user is somewhere else, they would go and connect to the Azure Virtual Desktop. And within there, those desktops are managed. They're registered, they're secured, they have all that stuff to then go and leverage all of the other services. So I'm leveraging that as a hopping off point to go and get those resources. So, I mean, obviously there's more expense there, there's more work there, but realistically, that's the world we live in today. So we think layers. I think, hey, I want the strong authentication in the first place to stop credential theft. And then I have to think about, okay, the attackers will change now what we target. They're going to try and target the tokens that have got generated. Those primary refresh tokens is the biggest one, but we're going to bind it so that I can do a proof of possession. So even if someone steals the primary refresh token, which they could if they had bad stuff, they wouldn't be able to use it. We try and stop the bad stuff getting there in the first place by managing though and applying policy and detecting with MDE. And then we still want to be able to detect it if it happens because nothing is perfect. We can do continuous access evaluation for apps that support it to be able to detect critical events, to understand the conditions around the policy like network location change. I can detect, hey, a critical event, the user risk has gone to high. And identity protection can help detect those token thefts. So that was it. My goal really was just to run through thinking about the credential and the token thefts and things you can do, things that exist. And honestly, one of the things I wanted to stress was the benefit of using the registered and the joined devices because I get this token binding. And again, this is growing. Microsoft are doing more things around this. And hey, I don't know what will happen with the standard, but I suspect there'll be something to enable compatibility with the broader ecosystem as well. But if I'm writing my own app, use the MSAL and it will future-proof you and take advantage of all of this stuff. Until the next video, stay safe and take care.